Good day, students. Today we'll be exploring a fundamental concept in algebra, the quadratic formula. Quadratic equations are second-degree polynomial equations, and they take the general form ax squared plus bx plus c, where a, b, and c are constants and x is a variable. Now here comes the superhero of quadratic equations, the quadratic formula. It's like a magic spell that helps us find the value of x using just one formula and is especially helpful when the equation cannot be factorized. To find x, you can use the formula. Start with negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Before we delve into examples, ensure you revisit the concepts of LCM and completing the square from previous videos, as they lay a solid foundation for what we're about to explore. We will start by learning how to derive this formula. First of all, we take a common and factor it out. It divides on the other side and goes away. Now complete the square by adding and subtracting the square of b divided by 2a. The first 3 terms can be combined, and the remaining 2 terms can be taken to the other side. Taking them to the right side changes the signs on the terms. The common denominator, or LCM, can be taken on these terms by multiplying and dividing c over a by 4a. The square root can be taken on both sides, and finally x can be isolated to give the quadratic formula. Now let's try an example which can be solved using factorization method as well, so you can do it yourself to confirm the answer. We have the problem 2x squared minus 5x plus 3 equals 0. First, identify the numbers. By comparing to the general form, we get a equals 2, b equals negative 5, and c equals 3. Let's apply the quadratic formula and plug in values. Negative of negative 5 gives us positive 5. Negative 5 squared inside the square. Root gives us 25. 4 times 2 times 3 gives 24. And this is whole divided by 2 times 2 or 4. We can simplify the expression inside the square root, which gives us the square root of 1, which is just 1. Now we can break it down into 2 solutions. For the positive square root, x equals 5 plus 1 divided by 4, which equals 6 over 4, and is simplified to 3 over 2. For the negative square root, x equals 5 minus 1 divided by 4, which becomes 4 over 4, and the simplified answer gives us 1. Time to move on to a more difficult example which cannot be solved using factorization. We will deal with the equation 3x squared plus 7x minus 2 equals 0. First, let's pinpoint the numbers. By matching it with the general form, we have a equals 3, b equals 7, and c equals to negative 2. Now, let's bring in the quadratic formula and insert our values. It becomes negative 7 plus minus the square root of 7 squared minus the product of 4, 3, and negative 2. And this is whole divided by 2 times 3, which is 6. As we simplify the expression inside the square root, we find that the value inside the square root is 49 plus 24, which is equal to 73. Breaking it down, we get 2 solutions. For the positive square root, x equals negative 7 plus root 73 whole over 6, and the negative square root, x equals negative 7 minus root 73 divided by 6. Factorization might have been tricky here, but the quadratic formula results in clear solutions.